This video will be about solving systems of equations using matrices. So when we have a system of equations, that is two equations containing both the letter x and the letter y. The first thing we need to be able to do with our system of equations is to write it as a matrix equation. So to do that, we take all the coefficients in front of the variables. That will make up one matrix. We take the constants on the other side. That will make another matrix. And we look and see what letters we have. We have the letter x and the letter y. So our first matrix would be 1, 2, 2, negative 3. All of the coefficients in front of the variables. Our second matrix would be the letters we are using, x and y, and that would equal our third matrix, which is just the constants on the other side of the equal sign. So now we need to solve this, and we're going to use some matrix operations to help us do that. First, we want to find the inverse of our coefficient matrix. So I'm going to call this matrix A, just so we have some way to talk about it. And I need to find the inverse. In order to find the inverse of a matrix, first I need to be able to find the determinant. To do the determinant, we take the top left and multiply times the bottom right. So 1 times negative 3. And then we minus the top right times the bottom left. It kind of forms an X. I kind of sort of think of it like cross-multiplying. It's a similar idea to help me remember. And I always remember top left because that's how we read stuff. We read top left to bottom right. So we multiply this out. 1 times negative 3 is negative 3. 2 times 2 is negative 4. That would be negative 7 as the determinant. If the determinant ever equals 0, then that means there is no solution. So if you ever get a determinant of 0, you can stop there. Our determinant is not 0, so we need to keep going. That hasn't actually found us the inverse yet. It's just our first step to finding the inverse. So when you find the inverse matrix, usually represented by a negative 1 to say, hey, this is the inverse, you will change these two spots. We switch the spots of the top left and the bottom right. So this will become a negative 3. This will become a 1. And in the other direction, you change the sign. So we would have negative 2 and negative 2. And the reason we found the determinant is because now we need to divide all of these by the determinant. We're going to divide every number by negative 7. I'm going to clean it up a little bit. There's not much we can do to clean this one up because 3 can't divide by negative 7. But if I have a negative over a negative, I get a positive 3 over 7. Negative over a negative again gives me 2 over 7. Negative over negative, and positive over negative stays negative. So this is our inverse matrix. Again, we're not quite finished. I now have to take this inverse matrix and multiply it by our coefficient matrix. Not my coefficient, I apologize, constant. They both start with the letter C, so I was mixing up the word. I'm going to call our constant matrix matrix B. So we need to now do A inverse times matrix B. So we know our A inverse is this 3 over 7, 2 over 7, 2 over 7, negative 1 over 7. Matrix B was negative 7, 0. So now we need to actually do our matrix multiplication. When you are multiplying matrices, it really helps to identify what size matrix do we have. This matrix has 2 rows and 2 columns. So this is 2 by 2. This matrix has 2 rows and 1 column, so it's 2 by 1. You can only multiply matrices if the middle two match, which they do. These can multiply, and your resulting end matrix would be the outside numbers. Our end matrix will be a 2 by 1 matrix. So we need a spot for 2 rows and 1 column. To actually multiply them, you do the first row times the first column. So you take the first term in the first row times the first term in the first column and multiply them. 3/7 times -7 plus the second term in the first row times the second term in the first column. So plus 2/7 times 0. Now we do this again, second row times first column. 2/7 times -7 plus -1/7 times 0. Now we simplify. -3/7 times positive 3/7 times -7 is -3. 2/7 times 0 is 0. 2/7 times -7 is -2. -1/7 times 0 is 0. Added together, we get -3. I'm not sure why I was writing that as a fraction. -3 and -2. And those would be our answers. If you go back up to our variable matrix, we know x is the top number, y is the bottom number. So x is -3 and y is -2. Or you could write it as the coordinate -3, -2.